In a triangle ABC, AB is equal to AC equal to 8 centimeters. A circle is drawn with BC as diameter passes through A. Obviously 12. With BC as diameter passes through A. That means it's a right angle triangle. It's an isosceles right angle triangle. Let's say it is ABC. A, B, C, 8, 8. Right angle. Another circle drawn with center A passes through B and C. So BC as diameter, this is our first circle, which center A passes through B and C. Our radius is 8. We have a circle like this. Nice. Radius is 8. We've got circle 1, circle 2. In the area in square centimeters of the overlapping region between the two circles. So we want to find, this is circle 1, this is circle 2. We want to find the overlapping region between the two circles, which is nice. That means we're going to count this entire semicircle and then calculate this segment. And so we're going to think of it as this entire semicircle. This semicircle has the diameter is 8 root 2 or the radius is 4 root 2. Area is pi 4 root 2 whole square by 2. 16 into 2, 32. 32 by 2. This is 16 pi. The 16 pi is in the bag. Okay. And then we need to find this thing, area of overlap between these two. Now we need to think about, in the bigger circle, C2 circle, what is the area of this segment? And so the area of sector minus area of triangle. Area of sector is 1/4 pi by 4 pi r square by 4 into 8 square minus half into 8 into 8. 8 square is 64. 64 minus 64 by 4 is 16. 16 pi minus 32. Our sum of this 16 pi plus 16 pi minus 32 is 32 pi minus 32. 32 times pi minus 1. Nice, juicy, simple question. You couldn't even guess this. The answer is more than 16 pi. Answer has got to have this triangle term. Not this, not this, not this. We'll get this at that point of time. Suppose the medians BD and C of triangle ABC intersect at a point O. Let's draw this. ABC, BD and CE. The area of triangle ABC is 108 centimeters. The area of triangle EOD, BD and CE. We want to find area of triangle EOD. Nice, brilliant. Right. How do we do this? Rather good question. The medians break the triangle into 6 parts of equal area. And so if I draw all 3 medians, all equal. Why? These two are equal, this is a median, these two are equal, this is a median, these two are equal, this is a median. And we can prove that each of these bigger chunks are equal to each other. The 3 medians break the triangle into 6 parts of equal area. And so this is totally 108. The total area is 108. So this will be 1/3 of that, 36. This is BOC. Right? And this one will be half of that, 18. This one will be half of that, 18. Nice, wonderful. So if we can find AED, I can find AEOD. Nice. If I can find AED, I'm through. I can find EOD. How do I find AED? AED is just half of ABC. This is half, this is half. This will also be half, midpoint theorem. Our area is 1/4 of area of triangle ABC. ABC area is 108. 108 by 4, this is 27. Out of the 108, we have accounted for 36 plus 36, 72. With 36 remaining, 27 is accounted for here, that's 9. 108 minus 27 minus 18 minus 18 minus 36, 9. Absolutely brilliant question. It really helps to know this. Really helps to know midpoint theorem, similarity. Area of AED is 1/4. But if you can just jot all of those down without having to process anything, this question becomes nicely doable. The lengths of all 4 sides of a quadrilateral are integer valued. If 3 of its sides are valued at 1, 2 and 4, then the total number of possible lengths of the 4th side is nice. 1, 2, 4. This would be the long 1, 2, 4. Right? So, simple rule of thumb, the sum of 3 sides of a triangle has to be greater than the 4th. Sum of any three sides of a quadrilateral will be greater than the 4th. Why? If I join this, these two are more than this plus this is more than this plus this, therefore is more than this. Just sum of 2 sides of a triangle greater than the 3rd, extrapolated. And so this fellow should be less than 7. 1 plus 2 plus 4 is 7. Fellow should be less than 7. Or it can be 6, 5, 4, 3, 2, 1. Except we need to keep in mind that the longest side could be 4. I have to flip the equation the other way around. Draw a triangle which is, say, x 1, x 1, 2, 4. X plus 1 plus 2 should be greater than 4. X should be greater than 4 minus 3, 1. X cannot be 1. This is ruled out. I can have 1, 2, 2, 4. That's possible. And 1, 2, 4, 6. That's also possible. But I cannot have 1, 1, 2, 4. We cannot have 1, 2, 4, 7. Or the values this can take are 6, 5, 4, 3, 2. How many values are there? 5 of them. 5 of them. Sorry. So, sum of any 3 sides of a quadrilateral is greater than the 4th one. Just sum of any 2 sides of a triangle greater than the 3rd one, applied twice over. One more layer to it. That's it. Nothing more than that. The length of each side of an equilateral triangle ABC is 3 centimeters. ABC 3, 3, 3. Let D be a point on BC such that area of triangle ADC is half the area of triangle ABD. D is some point here. This area is half of this. The height is the same. Bases should be in the ratio 1:2. Or BD is 2. DC is 1. Nice. The length of AD in centimeters is, we want to find AD. This angle is 60. We have 2 sides and the angle in between that. We can find this answer. How do we find this answer? We use the beautiful cosine rule. And so we know that AD square in that triangle is AC square plus DC square minus 2 times AC into DC into cos angle ACD. Direct plugging in of cosine rule, nothing else, but you've got to know cosine rule to have a crack at this. Or AD square equals AC square 3 square DC square 1 square minus 2 into 3 into 1 into cos 60, which is 1 by 2. Just 9 plus 1 minus 3. This is AD square, which is 9 plus 1, 10 minus 3, which is 7. Or AD is root 7. If you know cosine rule, this becomes super easy. If you don't know cosine rule, it's a complete nightmare. Take away from this, no cosine rule. Learn cosine rule. Regular polygons A and B have sides in the ratio 1:2. Interior angles in the ratio 3:4. This is A. This is B. Let's say A has n sides. B will have 2 end sides. Sum of interior angles of a polygon of n sides is 180 times n minus 2. So the average interior angle, each interior angle, the value of each interior angle is in the ratio 3:4. Sum of all interior angles divided by n will be each interior angle. Why? Because we're dealing with a regular polygon. A regular polygon is one where all sides are equal, all angles are equal. So each internal angle here is 180 into n minus 2 by n. Each interior angle here is 180 into 2n minus 2 by 2n. This is the total sum of all interior angles. Divide by 2n, that will be each internal angle. This is the sum of all internal angles. Divide by n, that will be each internal angle. This ratio is 3:4. Or cancel off the 180, cancel off the n. This 2 goes there. 2 into n minus 2, or we can cancel even the 2, it becomes n minus 1. N minus 2 is to n minus 1 is 3 is to 4. You have to cross multiply and simplify. 4n minus 8 is 3n minus 3. N is minus 3 plus 8, which is 5. Or the polygon A is a 5-sided polygon, which is a pentagon. Polygon B is a 10-sided polygon, which is a decagon. Then the number of sides of B equals 10. Very mechanical question, very simple question. You have to look at it and knock it off. In triangle ABC, altitude AD and BE are drawn to the corresponding bases. If angle BAC is 45 and angle ABC is theta, then AD by BE equals. ABC angle ABC is theta, angle BAC is 45. AD and BE are drawn to the corresponding bases. AD is the base, is the perpendicular to this. BE is the perpendicular to this. We need to find AD by BE. Ratio of the altitudes. Area can be written as half into base into height. Ratio of altitudes will be opposite of ratio of bases. So we can simplify to that, and then something else will open up. So area of this triangle is half into BC into AD. This is also equal to half into AC into BE. These two should be equal. So both are area. So half and half gets knocked off. BC into AD equals AC into BE. We want to find AD by BE. This goes here. It should be equal to AC by BC. We want to find AC by BC. Nice. Now AC by BC. We know A by sine A equals B by sine B equals C by sine C. So we know AC by sine theta, so angle opposite, equals BC by sine 45, angle opposite. BC by sine of ABC. We want to find AC by BC. AC by BC equals sine theta by sine 45, sine theta by 1 by root 2 sine theta, if that is there. Done. A half into base into height is half into base into height. So we know we want to find ratio of height. It's the opposite of ratio of bases. Once we know, we need to find ratio of bases. A by sine A equals B by sine B. We need finding ratio of sine of the two angles. One angle is theta and the angle is 45, sine theta by sine 45, which is root 2 phi theta. All the vertices of a rectangle lie on a circle of radius r. Nice. Radius r. If the perimeter of the rectangle is P, this is L, B, then the area of the rectangle is, we need to find LB. We know this is the right angle triangle. So L square plus B square, this is 2R. So L square plus B square equals 4R square. Nice. We know 2L plus 2B is equal to P, or L plus B equal to P by 2, or L square plus B square plus 2LB equals P square by 4. Subtract this from this. 2LB equals P square by 4 minus 4R square. And area of the rectangle is LB, divided by this should be P square by 8 minus 2R square. Divide this by 2, half of this, P square by 8 minus 2R square. Nice juicy question, should just be knocking it off. Trapezium ABCD has AD parallel to BC. AD, BC. Angle PAT is 90. Let's say AD, PAD is 90. BC is 3 and AD is 8. So BC is 3, don't have AD here. AD is 8. Nice. The perimeter of the trapezium is 36. Nice. 3 plus 8 is a given. I'm going to draw a line like this. Call it E. This is 3. AD is 5. 3 plus 3 is a given. Add this and this. Call this as height h. Call this as h. This is Pythagoras theorem. It looks like it's an integer. 5, 12, 13 works best. So put 12, put 13, put 12, see if it works. 12 plus 13 is 25, plus 3 is 28, plus 8 is 36. Okay, done. 5, 12, 13 Pythagorean triplet just fits naturally inside. We are through. What is the area in square centimeters? Area of this rectangle is 3 into 12, 36. This is half into 5 into 12. This 30. 36 plus 30 is 66 square centimeters. Half into base into height, length into breadth. 66 square centimeters, we are through. Let ABCD be a parallelogram such that the coordinates of the three vertices A, B, C are 1, 1, 3, 4 and minus 2, 8 respectively. Then the coordinates of the vertex D are nice. 1, 1 should be A. 3, 4, 1, 2, 3, 1, 2, 3, 4. Minus 2, 8. Say somewhere here. This is a parallelogram. So it goes like this, like this. It should be D. This is A, B, C somewhere there, and this should be D. How do we do this? We know these two lines are parallel. We know these two lines are parallel. So find slope of AB and BC. AB slope should be same as CD. BC slope should be same as AD. Let's find slope of AB. y2 minus y1 by x2 minus x1. 4 minus 1 by 3 minus 1. This is 3 by 2. CD should be 3 by 2. I'm guessing this is minus 2. Should be minus 4 or minus 5, minus 3. One of these two. I'm going for that. I'm plumping for one of those two. So minus 4, 5. Suppose we put D is minus 4, 5. C is minus 2, 8. D is minus 4, 5. Slope is 8 minus 5 by minus 2 minus 4, 2. Yes, this works. These two slopes are equal. Now we need to do the other slope. Before that, we can find this minus 3, 4, minus 2, 8 and minus 3, 4. Slope will be 4 by 1. So this doesn't work. We can go for this as answer. It looks from the diagram, it's going to be like that. I'm backing my diagram drawing skills. Sometimes it pays off, sometimes it doesn't pay off. Sometimes just plonking in coordinate slope of AB, slope of BC, slope of CD. We can't find CD, AB and BC, then find AD and CD, and then see if the slopes are equal, algebraically solve it, or go from choices. Minus 4, 5 should work. Slope of BC, this slope 3, 4 and minus 2, 8. 8 minus 4 is 4, minus 2, minus 3 is minus 5. Slope of AD is 1, 1. 5 minus 1 is 4, 4 by minus 5. Yep, that also works. This is the answer. Going from answer choices, after drawing a diagram, doing some nuance. You can substitute that as P, Q. Slope of AB equal to slope of CD, slope of BC equal to slope of AD. You can solve algebraically, get that, or you can plonk in from answer choices, or you can visualize the diagram and plonk the better looking answer choices. 0, 11 is going to be somewhere here. That doesn't work. 4, 5, that side won't work. One of these two, this works with.
The vertices of a triangle are 0, 0, 4, 0 and 3, 9. The area of the circle that passes through these 3 points. So we have a triangle. We want area of the circle that passes through these 3. We want radius of the circle, or we want circumradius. Lovely. This looks like an impossibly tough question. It is not. 0, 0, 4, 0, 3, 9. If you can visualize these points, this becomes much simpler. To start with, this is not a right angle triangle. This is not an equilateral triangle. This is not even an isosceles triangle. And all those appear to be clear. How do we find circumradius? We know only one formula. We know that area is ABC by 4R. We have to plug that in somewhere. And so, if you find area, we may be getting somewhere. This distance, the altitude, this is origin. This is 9. Area is half into 4 into 9. It is 2 into 9, 18 square units. If we can plug this into ABC by 4R, we get R. But we know this is 4. We know this is 3, this is 1. We don't know these two, but hey, we know these two because all we've got to do is plug in Pythagoras theorem. Square root of 9 square plus 3 square. Square root of 9 square plus 1 square. This is a complicated question, but not an impossible question. This is root 90, 81 plus 9. This is root 82. This is 4. Bam, we have our answer. Area is 18, which is root 90 into root 82 into 4. ABC by 4R. Or circumradius is root 90. Just take out a 9. 3 times root 10 into root 82 by 18. Root 10, root 82, take a 2 from here, take a 2 from here. 3 into 2, root of 5 into 41 by 18. 3 into 2 is 6, 6 by 18 is 1 by 3. So circumradius square root of 205 by 3. It's a vague number, but we don't want circumradius, we want area. Area is pi r square. So r square is 205 by 9, 205 pi by 9. Looks like an impossibly tough question. The random scalene triangle for which we have to find circumradius. We've not even been given the metrics, we've been given the coordinates. But the idea of being given coordinates, if the coordinates have one line parallel to x-axis or y-axis, life is simple, because then finding area becomes a walk. Finding the measures of the other sides becomes a walk. You don't need to plug in distance formula, you just need to plug in just Pythagoras theorem. But you need to have a certain comfort with coordinate geometry to visualize the shape. So when you're preparing for Cogeo, have complete geometry foundation in place and get a sense of how the plane works. Don't go to town memorizing formulae. That's just a nightmare. In a trapezium, AB is parallel to DC, BC is perpendicular to DC, ABCD, DC, say this is DC, this is 90 degrees, and AB is parallel. DC is 5, BC is 4, angle BAD is 45. So it's a diagram like this. Wonderful. We want to find area of the trapezium. Brilliant. I'm going to mark an E here, which makes this a rectangle. This is 4, this is 5. This is 4 into 5, 20. We've got that. After this, it's a walk, because the moment you know this is 45 degrees, it's an isosceles right angle triangle. This is 4, this is 4. This area is half into 4 into 4, which is 2 into 4, 8 units. This is 20, this is 8, 28 square centimeters. Good to go. Beautiful question. I really like this question. The area in square units enclosed by the lines x equal to 2, y equal to modulus of x minus 2 plus 4, and the x-axis and y-axis are equal to. Wonderful. X-axis is this, y-axis is this. X equal to 2 is a line parallel to the y-axis. So we've got this. These three we have in the back. 0, 0, x-axis, y-axis. We can somehow get this. We are through. We're going to get this slowly, methodically. We get this diagram shape, we are through. Fine. So for that, I'm going to go step by step. I'm going to draw y equal to mod x, because I know that. Y equal to x is a line like this. Y equal to mod x is a line like this. It will be 0 at x equal to 0. And this is y equal to mod x. Now I want to say I want to do y equal to modulus of x minus 2. Think about it. This will go to 0 when x is 2. Or this is nothing. Just shifting it to the right. Y equal to mod x is like this. Y equal to modulus of x minus 2 will be like this. How will y equal to modulus of x minus 2 plus 4 be? Add 4. 1, 2, 3, 4. It will be a line like this. Now take that to our original diagram. So this is 2, 0 and then 2, 4. You are looking at a line like this. This point is 2, 4. We put x is 2, y will be 4. That's a bottom for this. You're looking at a curve like this. This distance is 2 units. This distance is 4 units. There's a straight line. The angle is 45 degrees. The modulus of x line. This is 2. This is 2. this area is half into 2 into 2, 2 square units. This area is 2 into 4, 8, 8 plus 2, 10. If you know y equal to mod x, you should have a sense of y equal to modulus of x minus 2. If you know y equal to f of x, you know y equal to f of x plus 4. Just take it higher. Then you visualize the shape. Think of the trapezium. Think of a right angle triangle and a rectangle. Then you're through. The area of the region satisfying the inequalities mod x minus y less than or equal to 1, y greater than or equal to 0, y less than or equal to 1 is beautiful. Let's draw this one. Y greater than or equal to 0, this is this. Y less than or equal to 1, y equal to 1 is this region. We're talking about this band. Mod x minus y less than or equal to 1. Okay, mod x minus y equal to 1. Or y equals mod x minus 1. Now, y equal to mod x is a curve like this. Mod x minus 1 will be a curve like this. Shift it down by 1. So this is 0, 0. This is x-axis. This is a line y equal to 0. This is a line y equal to 1. We're talking about this band here. On top of, inside that band sits this y equal to mod x minus 1 line. So this point will be minus 1, 0, minus 1. Put x equal to 0, y will be minus 1. This point, when will y be 0? When x is 1, 1, 0, or x is minus 1, minus 1, 0. When will y be 1? So 1 equals mod x minus 1. Mod x should be 2, 2, 0, or minus 2, 0. Or this distance is 4. This distance is 2. We're talking about a trapezium of height 1 and sides, parallel sides 4 and 2. Half into 4 plus 2 into 1. Half of 6, 3 square units.
On a rectangular metal sheet of area 135 square inches, a circle is painted such that the circle touches two opposite sides. If the area of the sheet left unpainted is 2/3 of the painted area, then the perimeter of the rectangle. I'm going to draw the first diagram here. And so there is a breadth, there is a length to this. A circle is painted such that the circle touches two opposite sides. Obviously, it will be this. Right? If the area the circle is painted, area of the sheet left unpainted is 2/3 area of the painted area. That is, this area is 3, this area is 2. Right? Quite simply, we need to find a link between the radius and the length. Right? So, how do we do that? Let's assume a radius of this circle r. Right? B is 2r. L is 135 by 2r. Area is 135 square inches. Right? So, this area is 3. The overall area is 5. So, we can find area of the painted region. This is 135 into 3 by 5. So, 135 into 3 by 5 is pi r square. We figure that out, we are through. So, 135 into 3 by 5 equals pi r square. This is 135 by 5 is 27. 27 into 3 is 81. 81 by pi equals r square, or r is 9 by root pi. We want to find a perimeter of the rectangle, then the breadth is 18 by root pi, it is twice our radius. The length is 135 by 18 by root pi. 135 is a multiple of 9, it becomes 15. This is 2. It is 15 root pi by 2. Looking at 2 times length plus breadth. So twice of length is 15 root pi plus 36 by root pi. Looking for a choice that is 15 root pi plus 36 by root pi. Let us see whether that works out. We're taking a root pi out common. We can take a 3 out common. So we take a 3 root pi out common. There will be 5 left here plus 12 by pi. Yep. luckily enough, we have a choice that matches 3 root pi into 5 plus 12 by 5. That's the answer. And very interesting question, but no rocket science here. The key thing, this is 2/3 of this. Or if this is 3, this is 2. The moment you write the ratio down like that, we know area of circle is 3/5 area of the rectangle. Rectangle area is 135, 3/5 of that is 81. From that we get the radius. Twice of radius is breadth, 135 by breadth is length, and then add up and manipulate root pi and the rest of it. Fine. Lovely question, but not too difficult.
A circle is inscribed in a rhombus with diagonals 12 and 16. Diagonals 12 and 16. Nice little rhombus here. Diagonals of a rhombus are perpendicular bisectors of each other. So it will be 6, 8, 8, 6, 10, 10, 10, 10. A circle is inscribed inside this. Beautiful. Beautiful. So we want to find the ratio of area of circle to the area of the rhombus. Area of rhombus is very simple. Half into 6 into 8. 6 into 4, which is 24 square units in the bag. If we find area of the circle, we're through. If we find radius of the circle, we're through. Brilliant. How do we find that? Beautiful. How do we find that? Think about this. I spent a long time thinking about it. Very good question. Radius will be perpendicular to the side of the rhombus. Why so? Because tangent is perpendicular to radius. Side of the rhombus is a tangent to the circle. Right. So if you find radius, we are through. So I'm going to take one of these beautiful triangles carved out by half a diagonal and half a diagonal. This is 8. This is 6. This is 90 degrees. Drop this altitude. We are told that this is h. You can use the idea of similar triangles and get there. Or you can say, we can substitute areas are equal. Half into 8 into 6 is half into 10 into height. Area is base into height, half into base into height. Whether you take this as base, this as height, or this as base, this as height, area should be same. The half gets knocked off. Height is 48 by 10 or 24 by 5. The height of that right angle triangle is nothing but the radius. Or area of this circle is pi r square height. So this pi 24 by 5 into 24 by 5. That is the area divided by 24. Area of the rhombus. Half into 6 into 8. Area of circle to area of the rhombus. Area of the rhombus. Okay. Area of the rhombus is not half into 6 into 8. It is half into 12 into 16. 96. I made a mistake there, which is why I was worried none of the choices are matching. Thankfully, the choices are available for this one. It is 96 and not 24. I took half of the diagonal. It should be half into d1 into d2. I did half into d1 by 2 into d2 by 2. And so this is pi into 24 into 24 by 25 into 96. 24 by 96 is 1 by 4. 24 by 4 is 6. 6 pi by 25. Lovely. My original answer would have given us 24 pi by 25, which luckily enough was not there in the choices. It's half into product of diagonals, not half into product of half the diagonals.
Again, very interesting question. Let C be a circle of radius 5 meters having center at O. Let PQ be a chord of C that passes through the points A and B, where A is located 4 meters north of O and B is located 3 meters east of O. Then the length of PQ in meters is nearest to. Look at this one. Draw the circle. Center O. PQ is a chord of C. So let's draw PQ. Passes through points A and B, where A is located 4 meters north of O. So this is A, 4 meters north. And B is located 3 meters east of O. B, 3 meters. North and east, therefore this is 90 degrees. Right? This is PQ. radius of this circle is 5 meters. Lovely. We need to find PQ. How do we do that? We need to have some mechanism. Anytime you're dealing with chord and a circle, it's always good to draw the line from center of the circle to midpoint of the chord. That will be perpendicular to the chord. And then work from there. So draw this line. Call this as R. We find PR. We know that is same as RQ. Therefore, we can find PQ. Life is good. How do we find PR? If you join OP, that is 5 meters. OP is fine, 5. If you know PR, we can find OR. Or if you find no OR, we can find PR, Pythagoras theorem. Nothing more than that. How do you find OP? Very simple. Think about this triangle AOB. I'm going to draw this triangle. Make it bigger. AOB. We want to find OR in this. So this is 3, this is 4, this is 5. 3, 4, 5 Pythagorean triplet. From O, the perpendicular line here. Oops. This is OR. Right. Imagine this to be 90 degrees, a straight line. So this is OR. Half into base into height is area. OR is the height when the base becomes AB. So OR into 5 is 3 into 4. So half into 3 into 4 is half into OR into 5. The half disappears. OR is 12 by 5 or OR is equal to 2.4. So this measures 2.4. Now what do we do? I'm going to go to the next slide and draw just that part that I want to draw. OR is 2.4. Radius is 5. This is 2.4. This part is what we need to find. So this is square root of 5 square minus 2.4 square. 2.4 square is 5.76. So 25 minus 5.76, which is 19.24. So this distance is square root of 19.24. Our distance PQ equals 2 times square root of 19.24. 4 square is 16, 5 square is 25, 4.5 square is 20.25. So this is between 4 square and 4.5 square, closer to 4.5. So maybe this is 4.4, 4.35, something like that. Into 2, you're looking for an answer in the 8.7, 8.8 range. This works. Beautiful question. I'm going to go back one slide, look at this diagram again. We want to find PQ. We straight away say from center, draw a line to midpoint of PQ. That will be perpendicular to PQ. We know we want to find PR, which will be equal to RQ, or we want to find OR. How do we find OR? We look at triangle AOB. From that we find OR. We know OR, we know OP, we can find PR, Pythagoras theorem. And we are back here. Again, wonderful question. From an interior point of an equilateral triangle, perpendiculars are drawn on all 3 sides. The sum of the lengths of the 3 perpendiculars is S, and the area of the triangle is. And so there's one funda that you should know, but I'm going to assume we don't know that. We'll start from there. And so take a point here, dropping a perpendicular, dropping a perpendicular, dropping a perpendicular. And so you drop a perpendicular to 3. What will these 3 add up to? The question is saying the sum of those 3 is a constant for an equilateral triangle. Right? Now, one thing is to prove that it will be a constant. The other thing from an exam point of view is to say, okay, I'm going to figure out a point such that it's easy to calculate this. What will I do? I'll not select a point on the interior. I'll select this point. From this point, I'll drop a perpendicular here. From this point, I need to draw a perpendicular to that line. Nothing, just a point. This point perpendicular to this line, just a point. So those two don't add too much, or the total, nothing but the altitude. See if you can prove this. From any point on the interior of an equilateral triangle, if you drop 3 perpendicular to the 3 sides, the sum of those 3 perpendiculars will add up to the altitude of the equilateral triangle. And not rocket science, very easily provable. See if you can prove it. But from an exam point of view, you don't need to do that. Pick one point, you're good to go. Or you could have picked the centroid or orthocenter or circumcenter. They're all coincident. From that point, you could have assumed and then done this, or you'll always come back to this. This question effectively is saying S is root 3 by 2a. Done. So the sum of all this is root 3a by 2, or a is 2s by root 3. Area of the equilateral triangle is root 3 by 4 a square, that you should know. So therefore area is root 3 by 4 into 2s by root 3 into 2s by root 3. 1 root 3 gets knocked off. 2 into 2 is 4. S square by root 3. Yeah, luckily we have that. Good to go. And the sum of the three altitudes, sum of the three perpendiculars will be equal to the altitude of the equilateral triangle. That's one funda that you should know. After that, we're just plugging in the formula. Let's do this one. Really vague question. Right? So I'm going to read this and then tell you what my P with this is. The sum of the perimeter of an equilateral triangle and a rectangle is 90 centimeters. The area T of the triangle and area R of a rectangle, both in centimeter square, satisfy the relation R equal to T square. Hate these kind of questions where both of these are the same units and then you capture it in centimeter square and frame this equation. Like there are hundreds of ways to frame the equation without resorting to this. Fine. My P was side. We'll come back to this one. The sides of the rectangle are in the ratio 1:3. The length of in centimeters of the longer side of the rectangle is whatever it is. Fine. So the perimeter of equilateral triangle and a rectangle is 90 centimeters. I'm going to start with the rectangle. And so this is x, this is 3x, x, 3x. And so perimeter is 8x. Lovely. The area T of the triangle and area R of a rectangle, both in centimeter square, satisfy the relation R equals T square. And first of all, let's say side of the equilateral triangle is A, and area would be root 3 by 4 a square. And so R equals T square. So if you square this, that should be equal to area of the rectangle. So we take this and square this. That will be equal to area of the rectangle, which is 3x square. Root 3 by 4 a square, the whole square is 3x square. Lovely. So root 3 by 4 a square, the whole square is 3 by 16 a power 4 equals 3x square. A power 4 is 16x square, or a square equals 4x. Lovely. A square equals 4 times x. Now we can go on and say that the longer side of the rectangle, that's what we need to find. After this, we can even go on to trial and error, which is what I'm going to do. The longer side of the rectangle is 3x. We know that a square, let's go back here. We know a square is 4x. If 3x were 27, then x would be 9. Then 8x is 72. The remaining a, the side of the triangle, is 6. So x is 9, a is 6, a square is 36, 4 into 9 is 36. This works, this works. After that point of time, we can slip into trial and error and then simplify. If we want to still avoid trial and error, we know a square equal to 4x. We know 8x plus 3a equals 90. A square is 4x, so 8x would be 2a square. 2a square plus 3a minus 90 equal to 0. Solve that, we'll get some expression for a, and then we can simplify and solve for that. Fine. So a routine question, mildly irritating, at least I feel peeved by it because of that one expression, r equal to t square. I find it an annoying way of describing a question, otherwise very doable. C1 and C2 be concentric circles such that the diameter of C1 is 2 centimeters longer than that of C2, or radius of C1 is 1 centimeter longer than that of C2. If a chord of C1 has a length 6 centimeters and is tangent to C2, chord of C1 6 centimeters and tangent to C2. So C2 is inside, C1 is outside. This is C1, this is C2. A chord of C1, this is 6 centimeters, say it's AB, The point of tangent C will be perpendicular. It's concentric. This is 3. This is 3. This is radius. This is radius plus 1. Then the diameter of C1 is what we need to find. Join this. This is 90 degrees. This is R. This is R plus 1. 3 sides of a right angle triangle. 3R, R plus 1. I already know this. 3, 4, 5. Or the inner circle has radius 4 centimeters. Outer circle has radius 5 centimeters. The diameter of C1, find it to 10 centimeters. 3, 4, 5 Pythagorean triplet. You shouldn't be solving using Pythagoras theorem. 3 square plus R square is R plus 1 whole square. You can do that, but you shouldn't have to. Suppose the length of each side of a regular hexagon of A, B, C, D, E, F is 2 centimeters. T is the midpoint of CD. Then the length of AT in centimeters is excellent question. Regular hexagon E. Each side measures 2. T is the midpoint of CD. The length AT in centimeters. So let's draw this. So this is 2. This is 2. This is 1. Very interesting because we don't know. We want to find AT. If they're a diagonal, it is easy. The AD measures 4. AC is easy. AC measures. This is 4. This is 2 root 3. That is nice and simple. But we want to find AT. That's going to be interesting. How do we find AT? AD measures 4. AC measures 2 root 3. We want to find AT. Remember, AT is not perpendicular to CD. We can't just plug in Pythagoras theorem and simplify. That doesn't work. We cannot work like that. So we need to figure out some other mechanism of cracking this. So T is the midpoint of CD, 1 and 1. We can use some trigonometric ratio and then figure this out. We can find the angles and simplify. But hey, it's still tough. It's still tough because this is 60. And so this is 30. So this angle is 30. We know 2 sides. We can find we know all 3 sides, so we can find that angle, but we want to find AT, not anything else. Very interesting question, because this angle is 30. So this angle is 90. 2 root 3 and 1. So ACT is a right angle triangle. This is 1. This is 2 root 3. 80 perhaps we can find because it's 120 degrees the internal angle. This is 30, 30, 120, 30, 90. So 2 root 3 whole square, 3 into 2, 12, 12 square plus 1 square, it adds up to 13. There's a hypotenuse, 1, 1. So square root of 13 should work. Let me just check that. Perfect. And so I'm just going to go over this method because I think I've rushed through a little bit. I'm trying to find, first of all, I know that in a regular hexagon of side A, this diagonal is 2A, this diagonal is root 3A. Just Pythagoras theorem, no rocket science there. Plugging in that idea, 2, 2, 2 root 3, 4. In a regular hexagon, each internal angle is 120. So this is 120, it's an isosceles triangle, 30 and 30. This whole angle is 120, this is 30, this is 90. This diagram where I made the mistake, and I looked at this question and I kept on thinking angle ATC is 90. It's not the case. Angle ACT is 90. This is 2 root 3. This is 1. This is 90. So this is a hypotenuse of that triangle. Square root of 2 root 3 whole square plus 1 square. Square root of 12 plus 1 root 13. Done. I did all kinds of nonsense for this question. The area of a regular hexagon is equal to area of an equilateral triangle of side 12 centimeters, then the length in centimeters of each side of the hexagon. And so a regular hexagon of side A, area would be 6 times root 3 by 4 A square. This is equal to area of equilateral triangle of side 12 equal to root 3 by 4 into 12 square is equal to this. Equate this, we'll get A. And patently very regular question. So This root 3 by 4, root 3 by 4 gets knocked off. 144 by 6 is 24 equals a square. A is root of 24. You can extract a 4 outside, 2 root 6. That is there, we are through. It is there, done. Then the length in centimeters of each side of the regular hexagon is 2 root 6. A regular hexagon is 6 equilateral triangles. That's it, done. A circle of diameter 8 inches is inscribed in a triangle ABC, where ABC is 90. So, lovely. A, B, C, 90. BC is 10. Diameter 8. Or radius is 4. This is 4. This is 4. This is 6. This is 6. These two should be X and X. So, 10 square plus X plus 4 whole square equals X plus 6 whole square. Solve this, we should get the answer. Or these two are 2 apart. And 10 is one of the 5s. 5, 12, 13 into 2. 10, 24, 26. We are done. 10, 24, 26 is the triangle we are looking for. That means we are looking at 10, 24, 26. This triangle will take all the boxes. Area of the triangle is half into 10 into 24, 12 into 10, 120 square units. Half into base into height, half into 10 into 24, 120 square units. Why am I putting this in radius? This is 90, this is 90, so square. These two are equal, tangents from a point, these two are equal, radius, tangents are equal, 6 and 6, tangents are equal, 6 and 6, then Pythagoras theorem, we are through. A rhombus has an area of 12 square centimeters and side length 5 centimeters. Then the length in centimeter of its longest diagonal. Right. This is 5. My initial instinct was 3, 4, 5 and we are done. Within a rhombus, the diagonals are perpendicular bisectors of each other. 3, 4, 5 and we are done. That means the diagonals are 6 and 8. This is 6, this is 6, this is 8. Area would be half into product of diagonals, half into 6 into 8, just 24. Our area is only 12. So it's not a 3, 4, 5 triangle. Initially I thought 3, 4, 5 done, we're through. Coasting doesn't work like that. And so if this is A, this is A, this is B, this is B. We know that half into 2A into 2B is the area, that is 12. Or 2AB is 12. We know that A square plus B square is 5 square, which is 25. Nice. We want to find the longer diagonal. We need to find A or B. And so luckily we have A square plus B square and 2AB. Add these two. A square plus B square plus 2AB is 37. Subtract one from the other. A square plus B square minus 2AB is 25 minus 12, 13. Or A plus B is the root 37. A minus B is the root 13. The longer diagonal be root 37 plus root 13 by 2. Shorter diagonal be root 37 minus root 13 by 2. We want to find the longer diagonal, root 37 plus root 13 by 2. Wait a second, 2A is root 37 plus root 13. Remember, we put this in. A is half the diagonal. The answer is not this, it is this. 2A is the length of the diagonal, not A. We'd assume AA, B to be half the diagonal. Or the longer diagonal is root 37 plus root 13. Shorter diagonal is root 37 minus root 13. Half into product of the diagonals will be 12. That works. So the answer is root 37 plus root 13. Let D and E be points on sides AB and AC respectively. AB and AC respectively of a triangle ABC such that AD is to BD is 2 is to 1. 2x and x. And AE is to C is 2 is to 3. Area of triangle ADE is 8 square centimeters. Area of triangle ABC. Nice simple question. Area of a triangle PQR is half PQ sin R. This triangle, area of triangle AD is half into AD into DE into sine of angle A. Area of triangle ABC is half into AB into AE into sine of angle A. Sine of angle A is common, or half into sine A into 2x into 2y is 8. Half into sine A into 3x into 5y. What is this going to be? So divide one by the other. This is sine A, this will go away. 4xy goes with 8. 15xy would go with 30 into 3 by 2 into 5 by 3. So it's going to be 30. So 30 square units. The sides AB and CD of a trapezium ABCD are parallel, with AB being the smaller side. P is the midpoint of CD, and ABPD is a parallelogram. Nice. With AB being the smaller side. Nice. So A, B, C, D. P is the midpoint of CD. ABPD is a parallelogram. It's a parallelogram, so this should be X. Nice. The difference between the area of the parallelogram ABPD and the triangle BPC is 10 square centimeters. Then the area in square centimeter of the trapezium, this minus this is 10 to start with. This half into this height here. H. It will be the same height here. H. Area of the triangle is half into base into height. Area of parallelogram is base into height. Area of parallelogram will be 2 times this. So this area will be 2 times this area. This area is A, this area will be 2A. The difference is 10, or A is 10, this is 20. 20 minus 10 is 10. Then the area in square centimeter for trapezium ABCD is 30. 20 plus 10, 30. Lovely, easy question. Just knock it off the park. Let ABCD be a parallelogram. The lengths of side AD and diagonal AC are 10 and 20 respectively. The angle ADC is equal to 30 degrees. The area of parallelogram in square centimeter. It's a nightmare of a question. And I took a long time looking for a juicy method, and I didn't find it. And then I said, look, I'm going to brute force this. I don't know if there is a more elegant method than the brute force method. So I'm going to do it by the brute force method. In case there's an elegant method, please do chip into us. And so ABCD, ABCD, angle ADC is 30. This doesn't look 30. We'll live with that. AD and AC are 10 and 20. So this is 10. This is 20. And the area of the parallelogram in square centimeters is, this is 10. This is 10. Fine. So we need to find area of the parallelogram. So we need to find base into height. We don't know the height. I thought of using some trigonometry and finding the height. There's no direct way. If this angle were 30, brilliant. Half into half BC sin A. We're finding the area and we are through. It is not. We have to find some other way of doing this. We can find this using cosine rule. Somehow we can manage and find this side. Let's do that. And so 10 square plus DC square minus 2 into 10 into DC into cos 30 equals 20 square. This square plus this square minus 2 into product of these two into cos of this angle is that square. Cosine rule, a square plus b square minus 2ab cos c is equal to c square. We're plugging that in. Cos 30 is root 3 by 2. So 100 plus dc square minus 2 into 10 into dc into root 3 by 2 is 400. So dc square minus 10 root 3 dc equals 300. Or dc square minus 10 root 3 dc minus 300 equal to 0. It's a nice equation. We've got this. Luckily enough, I can see this straight away and then say we get only one value for dc. But the product of the roots is negative. One is positive, one is negative. So we don't have to worry about the negative root. Luckily, we'll get only one value of dc. If we manage to find that value of dc, we're through. We can then Then simplify this. 10 root 3, 5 root 3 whole square. I can split this in terms of completion of squares. 5 root 3 whole square is 3 into 25, 75. I can write this as plus 75 minus 75 and then go somewhere with that. I can simplify it like that. So I'm going to write this as dc square minus 10 root 3 dc plus 5 root 3 whole square equals 300 plus 5 root 3 whole square. This is dc minus 5 root 3 whole square equals 300 plus 75. dc minus 5 root 3 equals square root of 375. Nice. Square root of 375, we can take a 25 outside. This is 25 into 15. So dc equals 5 root 3 plus 5 root 15. Nice. So we've got dc by completing the square and all of that. We know AD is 10. So area of this triangle is half into AD into DC into sine 30 into 2 would be area of the parallelogram. So area of the parallelogram would be half into 10 into 5 root 3 plus 5 root 15 into sine 30 into 2. That's the number we're looking for. Half AB sine C for area of the triangle into 2 for area of the parallelogram. This is AD, this is DC. We found DC by plugging in cosine rule. AD was given half AB sine C, AB and sine of the angle in between into 2. That's what we're doing. So this 5, this get cancelled. This is 10 into 5 root 3 plus 5 root 15 into 1 by 2 or 5 into 5 root 3 plus 5 root 15 or 25 into root 3 plus root 15. Yep, this is here finally. Really complicated question, totally skip worthy. I don't understand what is being tested. We plug in cosine rule, find that side. Then we plug in sine rule, find the area of the triangle, multiply by 2, find the area of parallelogram. There's 1 out of n places where something can go wrong. Even the damn quadratic doesn't split naturally. So I saw the choices and I figured that, look, this involves some poking around with sine rule, cosine rule. Simply not happy doing this question. So it's one of those brute force, not elegant solutions. You gotta do it, yes, so you do it. Sometimes questions are like this, where we put our head down and say, look, I'm going to solve this through, no matter what. So that is what we end up doing. But from an exam point of view, skip worthy, not worth solving. The triangle ABC, angle BCA is 50 degrees. I mean, wonderful question, really challenging. I struggled with this. BCA is 50. So BCA, this is 50 degrees. The solving part of this question is very simple, but the diagram was a little weird. D and D are points on AB and AC respectively, such that AD equal to DE. AD is equal to DE. AD is equal to DE. Nice. F is a point on BC such that BD equal to DF. Find angle, then angle FDE in degrees. This angle. Right? I'm going to talk about angles A, B, and C of triangle ABC as angle A, angle B, angle C. Right? So this angle is angle B. This will also be angle B, isosceles triangle. This angle is angle A. This will also be angle A. Straight away, I can say this angle is 180 minus B. This angle is 180 minus A. What we need to find here is X. Or 50 degrees plus 180 minus B plus 180 minus A plus X equals 360 degrees. Why? 4 angles in a quadrilateral add up to 360 degrees. 180 plus 180 is 360. This goes away. 50 plus 180 minus B plus 180 minus A plus X equals 360. A plus B, A plus B is 130 degrees. So 50 minus 130 plus X equal to 0. Or 50 minus 130 is minus 80. X minus 80 is 0. X is 80 degrees. Isosceles triangle, isosceles triangle. It took me a while to draw the diagram. So very, I've not seen this diagram before. I wouldn't say non-intuitive. So I had to mark very carefully. This is equal to this, this is equal to this. After you draw the diagram, this becomes simpler. Isosceles here, A and A, B and B. 180 minus B, 180 minus A. This is given, we can find that. A plus B is 130, that much is clear. A park is shaped like a rhombus and has an area of 96 square meters. If 40 meters of fencing is needed to enclose the park, the cost in INR of laying electrical wires along its two diagonals at the rate of 125 per meter. Let's do this. This is a rhombus of side 10. The moment I see 10, I know that I'm tempted to think about 6, 8, 10. 6, 8, 6, 8, because a rhombus, the diagonals are perpendicular bisectors of each other. If this were 6, this were 8, this would be 8, this would be 6. Area would be half into 16 into 12, product of the diagonals, which is 8 into 12, 96, that works. So the moment I have hypotenuse 10, I'm thinking 6, 8, 10. Luckily enough, 6, 8, 10 works. This is a triangle we're talking about, this is a rhombus we're talking about. So along its two diagonals, along the 16 meter diagonal and the 12 meter diagonal, we're doing 16 plus 12 is 28. So along a 28 meter diagonal, we are plugging in 125 rupee per meter fence, 28 meters into 125. So this is 7 into 4 into 125, 7 into 500, or 7 by 2 into 8 into 125. This is 1000, this is 3.5, 3500 is the total cost. Rupees 3005, nice simple juicy question. Reward for powering through other tougher question. The cost of fencing a rectangular plot is 200 per feet along one side and 100 per foot along the other three sides. Let's say this is 100 per foot, 100 per foot, 100 per foot, 200 per foot. Let's say this is X, X, Y, Y. If the area of the rectangular plot is 60,000 square feet, then the lowest possible cost of fencing all four sides in INR. The cost of fencing would be 100Y plus 100X plus 100Y plus 200X. Or this is 300X plus 200Y. Okay. We know that X into Y area is 60,000. We want to find the minimum possible value of 300x plus 200y. 300x plus 200y should be as small as possible, and we should have a scenario where, and keeping in mind that x into y is 60,000. And so 300x plus 200y by 2 is greater than or equal to square root of 300x into 200y. 300x into 200y we can find. How do we find that? 300x into 200y, we know xy is 60,000. 300x into 200y we can find. Or the minimum value of this is that. Or the minimum value of 300x plus 200y is 2 times square root of that. Let's find that, we are through. The answer we are looking for is 2 times square root of 300x into 200y. X into y is 60,000, which is nothing but 200 into 300. So this is 300 into 200 into 200 into 300. So this is 2 times 60,000 or 1,20,000.
With rectangular axis of coordinates, the number of parts from 1, 1 to 8, 10 via 4, 6. So 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 1 to 8, 10. Somewhere here. Via 4, 6. where each step is from a point x comma y to either x comma y plus 1 or x plus 1 to y. This is very simple. From any point, you can either take one step up along a line parallel to the y-axis or one step across parallel to the x-axis. You either increase x coordinate by 1 or increase y coordinate by 1. Right? So I'm going to think about it as, first, let us worry about going from 1 comma n 1 to 4 comma 6. Then we'll worry about 4 comma 6 to 8 comma 10. By that time, our method should have been clearer. So I can take a horizontal step, another. I'll reach 4 comma 1. And then I took 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5, 4 comma 6. This is one way. But I could have done this or something like this. Any of those variants are possible. How do we compute how many variants are there? I'm going to do a very interesting method. I'm going to call this a vertical line. And I'm going to call this a horizontal line. So this first sequence will be h, 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 v, 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 v. The second sequence will be vh, vh, v, v, h. All possible such variants we must count. How will we count that? Effectively, h, 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 v, 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 v. In how many ways can this be reorganized? This we know is 8 factorial by 3 factorial into 5 factorial. Done. Do the same approach here. We are at 4 comma 6. 1 to 5, 6, 7, 8. 4 horizontal steps. 1, 2, 3, 4. 4 vertical steps. This is going to be all rearrangements of h, 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 v, 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 which is 8 factorial by 4 factorial into 4 factorial. Multiply the 2 and then we are home. So 8c5 into 8c4. Right? So 8 into 7 into 6 by 1 into 2 into 3 into 8 into 7 into 6 into 5 by 1 into 2 into 3 into 4. This is all we need to find. 2 into 3 is 6, gone. 2 into 3 is 6, gone. 8 by 4 is 2. 2 into 5, 10. 7 into 10, 70. 56 into 70. 7, 6 are 42, 2, 4. 35 plus 4, 39. 3920. That is the right answer. In a circle of radius 11 centimeter, CD is the diameter. Brilliant. 11 centimeter. CD is the diameter. So CD measures 22. Radius is 11. AB is a chord of length 20.5. 20.5. So it is very close. CE has a length 7. So I should mark this as D. This is C because I put the center here. I'll call this as E. CE is 7 or DE is 15. AB is 20.5. And the difference in length between BE and AE, what is that equal to? The idea we use here is very important. AE into EB equals CE into ED. The product of rectangles formed by two intersecting chords is identical. This into this is this into this. You prove this using similarity. And so try that, give it a shot. But now we know that 15, this is 15 into 7, CE into DE is AE into EB. These two add up to 20.5. So two numbers adding up to 20.5. Product should be 15 into 7. How am I going to find that? I'm going to write down 15 into 7 and find different combination. I'll divide this by 3. 5 multiply this by 3. 21. These two add up to 28. I need the total to add up to 20.5. There should be a 0.5 coming in somewhere. So I divide this by 2. 7.5 into 14. These two add up to 21.5. That's not working. So we need to simplify that. Let's do 15 into 7. Did not work. If you divide this by 2, you get 3.5 into 30. That obviously does not work. The numbers have to be closer to each other. Divide this by 3. 10 into 10.5. We have a winner. So 15 into 7 is same as 10 into 10.5. We're just juggling it around and then trying to see where it works. 15 into 7 is 105, which is 10.5 into 10, adding up to 20.5. So AE and BE are 10 and 10.5. The difference between these two is 0.5. Corners are cut off from an equilateral triangle to produce a regular hexagon H. Equilateral triangle T to produce a regular hexagon H. That means you're cutting off this corner, this corner, this corner. This is 120 degrees, it should be 60, 60. This will also be an equilateral triangle. This will be an equilateral triangle. This will be an equilateral triangle. The regular hexagon, all these are equal. Then equilateral triangles, so these two are equal. These two are equal. These two are equal. So this is a regular hexagon of side A, which is nothing but 6 equilateral triangles of side A. What is outside are 3 equilateral triangles of side A. Brilliant. In other words, our hexagon is 6 equilateral triangles. Our big triangle is 9 equilateral triangles. 9 equal equilateral triangles. I am considering this as one simple constructing block equilateral triangle. Or the ratio of area of H to T is 6:9, which is 2:3. Let T be the triangle formed by the straight line 3x plus 5y minus 45 equal to 0 and the coordinate axis. Let the circumcircle of T have a radius of length L. Coordinate axis are 2 sides. So it's a right angle triangle. And I have a circumcircle and a circumradius. You should already know, already be thinking, any right angle triangle, if you draw a circle around it, the hypotenuse will be the diameter, or the circumradius is half of hypotenuse. So let's draw this. 3x plus 5y equals 45. You put y equal to 0, we get x is 15. So 15 comma 0 is a point on this line. You put x equal to 0, you get y is 9. 0 comma 9 is a point on this line, or we have a line like this. A right angle triangle, sides 15 and 9. So the hypotenuse we can find out, just square root of 9 square plus 15 square. Circumradius, which is effectively L in our case, is half of hypotenuse, which is half of square root of 9 square plus 15 square. Brilliant. So this we need to find 9 square plus 15 square. We can take a 3 square outside. 3 square plus 5 square. So it is 3 by 2 times square root of 9 plus 25. 3 by 2 times square root of 34. 1.5 times square root of 34. Square root of 34 is roughly 6. Less than 6. So 3 by 2 times square root of 34 will be less than 9. And so we need to find it accurately. Maybe it will go to below 8.5. In which case the integer closest to L will become 8, not 9. It is close to 6, but less than 6. And so 3 by 2 of a number, if it has to be equal to 8.5, then this number be 8.5 into 2 by 3, 17 by 3. The square root of 34 is more than 17 by 3. We are good. It will go to, the number will round off to 9. If it is less than 17 by 3, it could round off to 8 also. Maybe 7. That we'll have to worry about later. I don't think it will go as low as 7. Right? So let's think about it. 34, 5.8 square root. 5.8, you're going to be given a calculator, so don't worry about it. But 5.8 square root, 58 square. I think it is 3364. So 33.64. And so that is close. 5.8 into 3 by 2 is 2.9 into 3, 8.7. Even if the square is 33.64, it goes to 8.7 rounded to 9. So square root of 34 will be more than that. It will definitely get rounded to 9. You're going to be given a calculator, but even otherwise, you can confidently say that the integer closest to L is 9. AB is the diameter of a circle of radius 5 centimeters. Let P and B be 2 points on the circle, so that the length of PB is 6. AB measures 10, radius is 5. P and Q be 2 points on the circle, so PB is 6. Length of AP is twice length of AQ. PB, so this is 10. So let's say P is here. PB is 6. Length of AP is twice that of AQ. Wonderful. Then the length in centimeters of QB was a very simple question. The right angle, the right angle, which is plugging in Pythagoras theorem. AB is 10. 10 is the hypotenuse, or AP should be 8. AP is 8. AP is twice of AQ. AQ is 4. We know that AQ square plus QB square is AB square. AQ square is 4 square plus QB square is 10 square. QB square is 100 minus 16, which is 84. So it is more than 9. So these two are out. Is it 9.1 or 9.3? 91 into 91 is 8281. 93 into 93. Let's just check that. 114 is 8649. Closest to 9.1. 9.1 into 9.1. It is closer to 9.1 than it is to 9.3. 9.2 would have been better, I think. 9.2 square would have been 8464. So 9.2 would have been closer to this than even 9.1. Between 9.1 and 9.3, 9.1 is definitely closer. 9.1 is the answer. Nothing but Pythagoras theorem applied twice over. Let us be the set of all points xy in the xy plane such that mod x plus mod y less than or equal to 2. Wonderful. Mod x plus mod y less than or equal to 2. I know this shape, mod x plus mod y equal to 2. Put x equal to 0, y has to be plus 2 or minus 2. Put y equal to 0, x is plus 2 or minus 2. This region is a set of straight lines. Zero comma 2, 2 comma 0, 0 comma minus 2, minus 2 comma 0. And mod x is greater than or equal to 1. Mod x equal to 1 will happen when x is 1 or minus 1. And so mod x is greater than or equal to 1. That is, mod x equal to 1, x equal to 1 would be a line like this. X equal to minus 1 would be a line like this. Mod x greater than or equal to 1 would be either this region or this region. Mod x plus mod y less than or equal to is the square, which is tilted and makes look like a diamond. Then the area in square units represented by s. Represented by s is this. What are the points here? This point will be 1 comma 1. This will be 1 comma minus 1. It will be minus 1 comma 1, minus 1 comma minus 1. This region. If you find one area, we can find the other. This distance is 2. Height is 1. So we have a triangle with base 2 and height 1. Area would be half into 2 into 1. Just 1 square unit. Here there is 1 square unit. Here there is 1 square unit. The area in square units represented by S is 2 square units. Wonderful question. You need to be comfortable with drawing the diagram for this, imagining this, and then drawing the diagram, finding the shaded region, and then simplifying that. In a triangle ABC, medians AD and BE are perpendicular to each other. And so let's see AD and BE. They're at 90. AD, BE. And have lengths 12 centimeters and 9 centimeters respectively. AD is 12, BE is 9. Again, this wonderful question. The question I properly struggled with. And so How do we do this one? Area of triangle ABC we need to find. So think about this. If we find area of triangle ABD, that into 2 will give us this. Becomes an easy question. Area of triangle ABE, that into 2 will give us this. And somewhere we can figure out the area. If we find area of triangle ABD, we are through. Area of triangle ABE, we are through. CBE, we are through. Somewhere. AD is 12, BE is 9. What this? Now this is the meeting point of these two medians, or this is a centroid. It's a delightful insight. The moment you know that you're through. How so? Centroid divides the median in the ratio 2:1. That means this AD is 12, AG is 8, GD is 4. BE is 9, this is 6, this is 3. Now what have we got here? We can find area of triangle ABE. How do we do that? That is just half into BE into AG. That is half into 9 into 8. 9 into 4, 36 square centimeters. Now that is going to be equal to area of triangle BEC, because B is the median, or area of triangle ABC is 36 into 2, which is 72 square centimeters. The other way of doing this, taking area of triangle ABD as half into 12 into 6. 36 into 2, 72. Meeting point of medians is centroid. Centroid divides median in the ratio 2:1. The median divides a triangle into two triangles of equal area. Those are the ideas we are using here. Once again, a wonderfully tough question. Once again, one that I struggled with, but beautiful. The moment you pick that centroid divides median in the ratio 2:1. Two circles, each of radius 4 centimeters, touch externally. Beautiful. Each of these two circles is touched externally by a third circle. So another external third circle. If these three circles have a common tangent, then the radius of the third circle, they have a common tangent. Brilliant. So third circle has to be here. Common tangent to these two, either this or this, or the tangent in between. Three common tangents. We have to draw a third circle for whom one of these lines also happens to be a tangent. In other words, we are being asked to draw a circle like this. This line cannot be a common tangent to three circles. We cannot draw a third circle for which this will also be a common tangent and it should also touch other two circles. That's not possible. And so the three circles have to be like this. Draw the center of this circle, center of this circle, center of this circle. Join these two, 4 plus 4, let's say call this as A, B, C, this is 4, this is 4. D, E, 4, 4. The point where it hits it, F, 4, 4. Join these two, again 4. Now what do we know? We know radius of this circle is R. These two circles touch each other externally. These two touch each other externally. We know AC equals 4 plus R. BC equals 4 plus R. Let's say this point is O. OF is 4. OC is 4 minus R. This is R, 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 4, 4. The whole thing is 4, 4 minus R. Let's say center of this point is P. We need to somehow find out CP, which is R. Find or OP, one of those. In all of these questions, somewhere along the line, Mr. Pythagoras is going to come into play. See if we can incorporate Pythagoras theorem somewhere. This lovely triangle POB gives us an opening. OB is 4. PB is 4 plus R. OP is 4 minus R. We are through. 4 minus R whole square plus 4 square equals 4 plus R whole square. Solve for this, we should get the answer. So I'm going to simplify that. 4 minus R whole square plus 4 square equals 4 plus r whole square. 16 plus r square minus 8r plus 16 equals 16 plus r square plus 8r. 116 gets cancelled. R square get cancelled. 16 equals 16r or r equal to 1. We have a famous 3, 4, 5 triangle. 3 square plus 4 square is 5 square. Radius is 1. Oops. Let A and B be two regular polygons having A and B sides. B is equal to 2A and each exterior angle of B is 3 by 2 times each interior angle of A. Each interior angle of B is 3 by 2 times each interior angle of A. I mean, regular polygon with n sides, the sum of the angles would be n minus 2 into 180. Each angle would be n minus 2 into 180 by n. So we know that A minus 2 into 180 by A is the regular each angle of the polygon with sides A, and 2A minus 2 by 2A into 180 is the each interior angle of regular polygon with sides with B sides. This is equal to 3 by 2 times this. 3 by 2 into this is this. Wonderful. So let's see how this works out. The A will get cancelled on both sides. 2 will get cancelled on both sides. So 180 will get cancelled on both sides. 3A minus 6 is 2A minus 2, or A is minus 2 plus 6, which is 4. B is 8. Then each interior angle in degrees of regular polygon with A plus B sides, that is 12 sides. Each interior angle would be 12 minus 2 into 180 divided by 12. This is 10 by 12 or 5 by 6. 180 by 6 is 30. 30 into 5 is 150 degrees. The base of a regular pyramid is a square and each of the 4 sides is an equilateral triangle. The length of each side being 20 centimeter. The vertical height. Wonderful. Pyramid is a square, and then there are 4 equilateral triangles rising from here. So 20, 20, 20, 20. I'm going to imagine one of those equilateral triangles. Let's say this one. And imagine that altitude there. So we have to use some form of Pythagoras theorem. And so I'm going to think about this peak of the pyramid down to the base of the pyramid. And that straight line is going to be perpendicular to the base plane. And that's the height of the pyramid. That's what we need to find. So this is base, and then from a point you draw to the center. This is what we need to find. This distance is what we need to find. Now, if you're imagining in terms of Pythagoras theorem, then you can imagine a straight line like this and this straight line. This straight line to that vertex, to the extreme vertices, those are sides of the equilateral triangle. But that right triangle, that triangle need not be, it's not a convenient triangle to look with, because that is from this point at the base. We want a line from the base to the side that will measure 10 centimeters. So if we can get this, we are through. That will happen to be the altitude of the equilateral triangle. Brilliant. So if you're looking at this, then we need to find this. We can find this as a slant height. This is 20. So this is 20 root 3 by 2 or 10 root 3. This is 10 root 3. We need this. The base is 10. So we're looking at a right angle triangle where the altitude h is what we need to find. The hypotenuse is 10 root 3 and the third side is 10. 10 square plus h square is 10 root 3 the whole square, or h square is 300 minus 100, which is 200, or h is 10 root 2. The other way of doing this, you can say, let's deal with this. This measures 20 and deal with this diagonal, which is 10 root 2, and then find h. That will also be a right angle triangle. So use that approach and say if you will get the right answer. Same answer. One side is 10 root 2. The hypotenuse is 20. Find the third one. That should also yield the same answer, 10 root 2. On a triangle ABC, a circle with diameter BC is drawn, intersecting AB and AC at points P and Q. Wonderful. So ABC. So let's say this is BC, it's an A here, ABC. We are drawing a circle with diameter BC. Draw a circle like this. And intersecting AB and AC at points P and Q respectively. This is P, this is Q. AB, AC and CP. AB is 30, AC is 25, CP is 20. And then the length BQ in centimeters is, we need to find BQ. Key thing here, this is semicircle, so this should be 90 degrees, this should be 90 degrees. So now we are looking to do Pythagoras theorem. So think about triangle PAC. So PAC. If you look at this triangle, this is 90 degrees, CP is 20, AC is 25. This is a ratio of 4:5, or this should be 3, 15, 20, 25 is a Pythagorean triplet. AP is 15, that means PB should be 15. Fine. Wonderful. I know our triangle, our line BA, it does not look like P is a midpoint of BA, but that's what the math is telling us. So this is 15, so this is 15, this is 20. PC, so I'm looking at triangle BPC now. BPC, this is 15, this is 20, this should be 25. Wonderful. So we've got BC to be 25. Now we need to find BQ. Now the best way to do this is using the idea that area of the triangle is half into base into height, which is half into 30 into 20, half into AB into PC. This also is half into 25 into BQ. 25 is nothing but AC. Plug this in and then you're through, we'll be able to find BQ. This half and half disappear. 25, take off a 5, make this 6, take off another 5, make this 4, 6 into 4, 24. BQ is 24 centimeters long. Wonderful, wonderful question. Pythagoras theorem and the idea that area is half into base into height. From a rectangle ABCD of 768 square centimeters, a semicircular part with diameter AB and area 72 pi square centimeters is removed. Diameter AB, area is 72 pi. Area is pi r square by 2, that is 72 pi. The pi gets cancelled. R square is 144 or R is 12. The radius of this semicircle is 12. The diameter is AB, or AB should be 24. So we have an ABCD which measures 24 like this. A semicircle is cut off. Right? AB is 24, area is 768, AB into CD, sorry, AB into BC is 768. 24 into BC is 768. Make it 12, make it 384, make it 6, make it 192, make it 3, make this 96, or BC is 32. The 32, this is 32, this is 24. Now we want to find the perimeter of the leftover portion. This is the perimeter. This is the leftover portion. Perimeter will be AD plus DC plus BC, and then half the perimeter of this circle. 32 plus 24 plus 32, 64 plus 24, 88, and then pi r, 2 pi r by 2, where r is 12, 88 plus 12 pi. A chord of length 5 centimeters subtends an angle of 60 degrees at the center of a circle. 60 degrees at the center of a circle. Center of a circle, 60 degrees, we know the radius straight away. I love this question because I know this number. I like this number. Chord of length 5 centimeters. makes an angle of 60 at the center. Think about this. 60. Any chord and angle at the center, these two are radii. These two are equal. Now this is 60 degrees. That means these two angles are equal. They are also 60. Or our circle has a radius of 5. Now angle of 120 at the center. The length in centimeters of a chord that subtends an angle of 120 at the center. This is very simple. This is trigonometry 101. This is 120. This is 5. So this angle is 120. This should be 60. This should be 60. This is 60. We know how to find this. How do you find that? This is 30. This will be. Let's name this. If you've not got the answer, pause. Sine 60 is BC by OB. Root 3 by 2 equals BC by 5, or BC equals 5 root 3 by 2. BC is 5 root 3 by 2. AC is 5 root 3 by 2. AB is 5 root 3 by 2 plus 5 root 3 by 2, which is 5 root 3. And it really helps to know that the moment you have a 60-degree angle at the center, you're talking about an equilateral triangle. So the radius is 5. In a 120, 30, 30 triangle, the sides are in the ratio 1:1 root 3. It helps if you know that, but it's not required. You can just plonk in this, do some trigonometry, and then get to the answer. Area of rectangle and the square of its perimeter are in the ratio 1:25. L into B is to 2 times L plus B whole square is 1:25. I'm going to write down this equation and then figure this out. LB is to 2 times L plus B whole square is 1:25. We need to find the ratio B is to L, shorter to longer side. And so L into B equals 4 times L square plus 2LB plus B square is 1:25, or LB is to 4L square plus 8LB plus 4B square is 1:25, or 25LB equals 4L square plus 8LB plus 4B square. 4L square minus 17LB plus 4B square is 0. Can be split as 16 and 1. We're going to get a ratio 1:4. Fine. So 4L square minus 16LB minus LB plus 4B square is 0. 4L into 4L minus 4B minus B, sorry, 4L into L minus 4B minus B into L minus 4B is 0. So 4L minus B into L minus 4B is 0. 1:4 or 4:1. Shorter to longer is 1:4. And just plain old-fashioned writing of equations, simplifying that. We're looking to solve for B by L. If you want to deal with only one variable, you don't like factorizing like this, divide by L square throughout. So you'll get 4 minus 17B by L plus 4B by L whole square equal to 0. B by L is what we want to find. We'll have 4 minus 17x plus 4x square equal to 0. X is what we need to find. You can simplify and find that. If you don't like dealing with a quadratic equation that has L and B, then create a B by L by dividing by L square throughout, and then you're done. You're dealing with only one variable. A parallelogram ABCD has area 48 centimeters square. Fine. CD measures 8. ABCD. CD is 8. Our AD measures S. The height here is 6 centimeters. So this height is 6. Then which one of the following is necessarily true? See, this is the right triangle with 6 as the height and S as the hypotenuse. So S is greater than or equal to 6. That we know for sure. It cannot be less than 6. So this works. Not equal to 6, we cannot say. Between 5 and 7, no. Less than or equal to 6, no. This is it. Length into height is area, breadth into height is the area, base into height is area, base into corresponding height is area. The height is 6. That means the side should be at least 6. If this were a rectangle, S would be 6. Otherwise, it will be greater than 6. A triangle ABC has area 32 square units and its side BC of length 8 units lies on the line x equal to 4. Fine. X equal to 4. Let's say 1, 2, 3, 4. X equal to 4 is a line parallel to the y-axis. This is 0, 0. This is the line x equal to 4. So BC measures 8 units and it's somewhere here. It lies on this. It could be cutting the x-axis. It could be completely in the first quadrant. It could be completely in the fourth quadrant. That line segment. Area 32 square units. Since we have this, let's take this as the base. Half into base into height is 32. Half into 8 into height is 32. Or height is 8 units. Remember, this is vertical distance. So if A were placed at a distance of 8 units from this line, means either at the point x equal to 12, somewhere here, or on the line x equal to -4. Anywhere here, and BC can be anywhere and A can be anywhere here. From A to BC, the distance would measure 8. The shortest possible distance between A and the point 0, 0. This is the point 0, 0. A can lie anywhere here or anywhere here. So the shortest possible distance A should be here on this line. This distance is 4 units. Done. A should be -4, 0. B and C could be any 2 points such that the distance is 8 units lying on the line x equal to 4. And very simple question. Once you get a reasonable sense of the diagram, and choose the base to be BC. Given an equilateral triangle T1 with side 24 centimeters. Wonderful. So T1 has side 24 centimeters. A second triangle T2 is formed by joining the midpoints of the side T1. T2. So T2 will also be equilateral. So this will be 12, 12, 12, 12, 12, 12, 12. Everything gets broken into half. Every length gets broken into half. So this is 12, 12, 12. Then a third triangle T3 is formed by joining the midpoints of T2. Wonderful. T3 will be like this. If the process of forming triangles is continued, then sum of the areas in square centimeters of infinitely many such triangles. Oh, wonderful. Find area of T1, then T2, then T3. To start with, these will form a geometric progression. Why so? Because we've been asked for an infinite series. It has to be diminishing. I can sense that it is going to be a GP. So this has 24, 24, 24. This has 12, 12, 12. Every side is halved, or area will be 1/4. So find T1. Area of T2 will be 1/4 of that. Area of T3 will be 1/4 of that. Let's find T1 area first. T1 area is √3/4 a square, which is √3/4 into 24 into 24. 24/4 is 6. 6 into 24 is 144. This is 144 √3. This is the first term. Common ratio is 1/4. We're looking at a by 1 minus r. 144 √3 by 1 minus 1/4, which is 144 √3 into 4/3. This is 48 into 4, 96 into 2, 192 √3. That's what we're looking for. And there's a geometric progression involved, and then we plug in √3/4 by a square, and then we do a by 1 minus r. Done. A right circular cone of height 12 feet stands on its base, which has a diameter of 8 foot. So diameter of 8 feet, radius of 4 feet, height of 12 feet. Okay. The tip of the cone is cut off with a plane which is parallel to the base and 9 feet from the base. So the overall height is 12 feet. 9 feet from it, we cut off one layer. Right? So the remaining would be 3 feet. Let's say this is O, B, C, A, D. OAD is similar to OBC. And so if this is 4, OB is 12, we know OA is 3, AD should be 1. The height crashes by 4, radius will also crash by 4. In the sense that height goes from 12 to 3, the radius will go from 4 to 1. So we've got this is 3, this is in the ratio 3:1, which is 12:4. With pi equal to 22/7, the volume in cubic feet of the remaining part of the cone, this is the remaining part of the cone, this is called a frustum. We need to find the volume, which is pi r square height, 1/3 of this, minus 1/3 of pi r square height. The big cone minus the small cone. So 1/3 into 22/7 into 4 square into 12 minus 1 square into 3. 1/3 into 22/7 into 3 into 64. 4 square into 4, I'm taking out a 3 minus 1. Or this is 1/3 into 22/7 into 3 into 63. This goes off. 63/7 is 9. We're looking at 22 into 9 equal to 198 cubic feet. 1/3 pi r square height minus 1/3 pi r square height. Large cone minus small cone. That's the volume of the frustum, remaining part. Large cone has radius 4 and height 12. Small cone has radius 1 and height 3. So 4 square into 12 minus 1 square into 3. So this is 3 times 63, and then multiply that and get to the answer. Let ABCD be a rectangle inscribed in a circle of radius 13 centimeters. Oops, 13 centimeters, radius, circle. This gives me a lot of joy. I love 13 centimeters, and you'll kind of see why. The moment I see 13 centimeters, I'm jumping up and down with joy. ABCD is a rectangle. So think about this. A, B, C, D. Radius is 13. So if I join the diagonal here, that will be the diameter, which is 26. 13 is part of 5, 12, 13. 26 is part of 10, 24, 26. There's no reason to choose 13. 13 is not a nice round number. 13 would most likely be chosen because you're thinking about 5, 12, 13. So I have an eye open for 10, 24, 26, 5, 12, 13 straight away. Which one of the following pairs can represent in centimeters the possible length and breadth of ABCD? Could easily be 10 and 24. There are million other possibilities, but 10 and 24 definitely works. If that's sitting in the choices, I'm marking that, and as luck would have it, that is there. The moment you see a 13 or a 26 or a 3, 4, 5 triplet or 8, 15, 17 sitting somewhere there, then your eyes need to go up. You need to be thrilled by seeing that and chase the Pythagorean triplet. Sector of a circle. In a circle with center O and radius 1 centimeter, an arc AB makes an angle of 60 degrees at O. I always like these 60-degree angles. Makes my heart go warm and fuzzy. So 60 degrees. So beautiful 1/6 of a circle. AB here. Center O, radius is 1 centimeter. What have we got? Let R be the region bound by the radii OA, OB and the arc AB. So the sector is R. Is C and D are 2 points on OA and OB such that OC is equal to OD. Wonderful. So OC, OD, these two are equal. Let's say A and A. So it's an equilateral triangle OCD. The area of triangle OCD is half that of R. Area of triangle OCD is half of R. So root 3/4 A square is half the area of R. This region R. We need to find A. Root 3/4 A square is half into 1/6 of pi into 1 square. This is 2, this is 3, or A square is pi by 3 root 3. or A is square root of pi by 3 root 3, not this, not this, not this, this one. Wonderful question. So all we need to do is equilateral triangle is root 3 by 4a square, which is half of 1/6 of a circle, and we're done. In a parallelogram ABCD of area 72 square centimeters, CD and AD have lengths 9 centimeter and 16 centimeters respectively. So AD is longer. I'm going to keep that in mind. So diagram like this. So let's say we have A, B, C, D. This is 16, this is 9. Area is 72 square centimeters, which basically means that this height is 72 by 16 and the other height is 72 by 9, 8. Let P be a point on CD such that AP is perpendicular to CD. We'll draw a perpendicular from A to CD. It's not going to be on CD, it's going to be outside, which is all right. Let's say this point is P. Right. We know that AP measures 8. The area in square centimeters of triangle APD is what we need to find. This is 8, this is 16. This should be 8 root 3. We're talking about 1 is to root 3 is to 2. The 30, 60, 90 triangle. 1 root 3 2. This is a right angle triangle. This is 16. This is 8. How is this 8? Because base into height is area. This is 9. This should be 8. 8, 16. This should be 8 root 3. Area of triangle APD is half into AP into PD, half into 8 into 8 root 3, which is 32 root 3. Wonderful. One step for finding area to find the altitude. Once you have the altitude, we have a right triangle, Pythagoras theorem, 1 root 3 2 triangle, done. So you should be very comfortable with the triangle, which is 1 root 3 and 2 and 1 1 root 2. This is 1/2 of an equilateral triangle. This is an isosceles right angle triangle, or 1/2 of a square. In a circle, two parallel chords on the same side of a diameter have lengths 4 and 6 centimeters. So let's draw this circle. Center here, one measures 4, one measures 6. The parallel chords, distance between them is 1 centimeter. From the center, draw a line perpendicular to one chord. It will be perpendicular to the other chord. This is 2, this is 3. Say this is AB, CD, PQ. PQ is 1. Let's say this is X. Very simple question. Anytime you have any of these questions with chords and circles, draw a line from center of the point to end point of the chord. Draw a line to midpoint of the chord. You get right angle triangles. When you have two right angle triangles, OQB and OPD. If this is X, this is 3, and this is R. This is radius, this is 2, this is x plus 1. 2 square plus x plus 1, the whole square is r square. 3 square plus x square equals r square. This increases by 1, this decreases by 1, and 1 offsets the other, or this should be 3 square, it should be 2 square, done. Or x is 2. The radius r square is nothing but 2 square plus 3 square, or nothing but 4 plus 9, which is 13, or radius is square root of 13. Done. E, F, G, H lie on these sides. EFGH is also a square whose area is 62.5% of that of ABCD, and CG is longer than EB. So E is here, F is here, G is here, H is here. 62.5% is a lovely number. 62.5% is 5 by 8. Now this is a square. Either EFGH could be bang in the middle or somewhere in the corner. Right? So remember, this has to be a symmetric figure inside, otherwise the EFGH won't be a square. We know EB is shorter than CG. So if E were here, F here, G here, and H here, this would be a square. Right?
We want to find ratio of the length of EB to that of CG. Fine. If this is 1 and this is R, we want to find 1:R. We effectively want to find R. Remember, if this were R, this would be R, this would be R, this would be R. This is 1, 1, 1. We're talking about ratios, nothing more than that. Fine. So now this question becomes very simple. We use a little bit of Pythagoras theorem. We can find that this EF is square root of 1 plus R square. So area of square EFGH is square root of 1 plus R square the whole square. Area of square, this is area of square EFGH. Area of square ABCD is 1 plus R the whole square. We are through. So we know that square root of 1 plus R square is 5 by 8 times 1 plus R the whole square. 1 plus R square into 8 is 5 times 1 plus R square plus 2R. So 8 times 1 plus R square, 5 times 1 plus R square, 3 times 1 plus R square equals 10R. 3R square minus 10R plus 3 equal to 0. This is 3R minus 1 into R minus 3. R is either 1/3 or 3. We know that EB is less than CG. EB to CG cannot be 3:1, it is 1:3. Remember, an equation of this type where you're doing a ratio, there is every chance that your answers are of the form K and 1 by K. The algebraic equation cannot distinguish between CG to EB and EG to CB. This part, CG is longer than EB, makes our life simpler and says it has to be 1:3 and not 3:1. So when you're solving, keep that in mind. That way this factorization becomes very simple. Time to travel. Let ABC be a right angle triangle with BC as hypotenuse. I love right angle triangles. AB and AC are 15 and 20. 15 and 20 is the ratio 3:4. So I know this is a 3, 4, 5 triangle. So AB is shorter, AC is longer. BAC 15, 20, 25. 3, 4, 5. The minimum possible time in minutes required to reach the hypotenuse from A at a speed of 30 kilometers per hour. From A, we reach the hypotenuse. When the minimum possible distance would happen, the minimum possible time would happen if you're traveling the minimum possible distance, which means it's a perpendicular line. And so we want to find distance AD and then divide that by 30 kilometers per hour. How do we find that? We can use the idea of similar triangles, but better still would be area of this triangle ABC can be written as half into BA into AC or half into BC into AD. It's probably the best method to find the altitude to the hypotenuse. Or 15 into 20 into half equals half into 20 into 80. Half into 25 into 80. Half disappears. This is 5, this is 3, 4, AD is 12 units. You're traveling 12 kilometers at 30 kilometers per hour. This is 2 by 5 of an hour, or 2 by 5 into 60, 24 minutes. We want the time in number of minutes, that is 24. Fine. Pythagoras theorem, finding the altitude and then doing distance by speed equal to time. The area of the closed region bounded by the equation mod x plus mod y equal to 2, the two-dimensional space is fine. I know this question, I know this shape, so I'm going to rush to the answer and then we'll discuss how we can get this. Mod x plus mod y equal to 2 is a shape like this. How do we get that? In all of these questions, put one of the two is 0. Put y equal to 0, x could be 2 or minus 2. So 2, 0 and minus 2, 0 sits here. A symmetric shape. Therefore 0, 2, 0, minus 2 also sit. If x and y are both positive, that is, we are in this quadrant, mod x plus mod y equal to 2 is just x plus y equal to 2. You have a straight line like this. 1, 1 will be on this. Therefore minus 1, 1 will be minus 1, minus 1 will be 1, minus 1 will be.
So we can see this graph take shape step by step. I already know this, so I'm rushing to the answer. But rule of thumb, whenever you have a curve like this, put y equal to 0, see where it cuts the x-axis. Put x equal to 0, see where it cuts the y-axis. You have modulus here and modulus here. That means if a point p comma q sits on this, p comma minus q can sit on it, minus p comma q can sit on it, minus p comma minus q can sit on it. The way it looks in the first quadrant, everything else is going to be symmetric of that. Therefore, if you draw this, you can frame the whole thing. So mod x plus mod y equal to 2. This distance is 2. This distance is 2. So this is 2 root 2. Area here is 2 root 2 into 2 root 2. It's a square of side 2 root 2. 2 root 2 to 2 root 2. That is 8 square units. Let ABC be a right angled isosceles triangle with hypotenuse BC. So I am already liking this question. I like isosceles right angled triangles. BCA. The sides are in the ratio 1:1 is to root 2, and the angles are 45, 45, 90. Let BQC be a semicircle away from A with diameter BC. The other semicircle would have passed through A because of the right angle. Let BPC be an arc of a circle centered at A and lying between BC and BQC. If AB has length 6 centimeters, so BPC be an arc of circle centered at A and lying between BC and BQC. So it's an arc like this. Wonderful. If AB has length 6, the area in square centimeters of the region enclosed between BPC and BQC. We're looking at this. Again, it's a standard question, but we'll solve this through to completion anyway. Right? How do we do this? We find area of, this is Q, this is P. Right? So we find area of the semicircle BQC. From that, we subtract area of this segment BPC. How do we find area of this segment? This is 1/4 because it's a right of pi into 6 square. So 1 quadrant of a circle of radius 6 minus half into 6 into 6. So this segment is 1/4 of pi into 6 square minus half into 6 into 6. So sector minus triangle gives us this segment, right? Which is 1/4 of 36 pi, 9 pi minus 18. Now this we need to subtract from the larger semicircle. Semicircle BQC that has BC measures 6 root 2. So radius of that semicircle is 3 root 2. Area is pi into 3 root 2 whole square into 1/2, which is pi into 9 into 2 into 1/2, or 18, 9 pi. From 9 pi, we subtract 9 pi minus 18. 9 pi minus 9 pi minus 18, which is 18 square units. Which is effectively area of this triangle. So this part is equal to area of this triangle. It's another way of thinking about it, which is linked to the idea that that you're talking about we're incorporating Pythagoras theorem in some form. So area of this triangle is half into 6 into 6, 18, which is nothing but area of that crescent shape. A solid metallic cube is melted to form 5 solid cubes whose volumes are in the ratio 1:1:8:27:27. We add all of this, 27, 27, 8, 1, 1. It adds up to 64. So we could have imagined a large cube of size 4 by 4 by 4. It would have had 64 pieces. Then we have 1, 1, 8, 27, 27. And the percentage by which the sum of the surface areas of these 5 cubes exceeds the surface area of the original cube is nearest to. Original cube has area 6 into 4 square. These are the 5 small cubes. They will have radii one side of the cube equal to 1, 1, 2, 3, 3. So area would be 6 into 1 square plus 1 square plus 2 square plus 3 square plus 3 square. So from 6 into 4 square, it goes to this. Think about percentage increase. So we just need to worry about the ratio. 4 square is 16. So we can forget about the 6. 1 plus 1 plus 4 plus 9 plus 9. This 9 plus 9 is 18. 18 plus 6 is 24. 16 to 24. It's an increase of 8. 8 or from a base of 16, or we are looking at 50%. A ball of diameter 4 centimeters is kept on top of a hollow cylinder standing vertically. So hollow cylinder standing vertically. The height of the cylinder is 3 centimeters. Its volume is 9 pi centimeter cube. Pi r square height is 9 pi. R square into 3 is 9, or R is root 3. Radius is square root of 3. A ball of diameter 4 centimeters is kept. Then the vertical distance in centimeters of the topmost point of the ball from the base of the cylinder. It's a wonderful question. So the diameter here is 2 root 3. So when you place a ball of diameter 4 centimeters, 2 root 3 is 3.4. So this ball is not going to go through this and fall in. It's not going to be held at its peak here, but it's going to be something like this, right, with the center being somewhere here. Now think about this. From the center of the ball, draw if you draw a line to this point, the midpoint, then diameter is 4, or this is 2. This is root 3. And so if you imagine this shape, then this point, the center of the spherical ball that is sitting on top of the cylinder, to the center of the circle that is the topmost layer of the cylinder, let's say that is P, and the end point which is of that diameter, basic diameter, let's say Q, and this shape OPQ is a right angle triangle. This is root 3, this is 2, this is a 1 root 3 2 right angle triangle. OP is 1. So the center of our ball of diameter 4 centimeters is 1 centimeter above the top circle of this cylinder. So we want to find the topmost point here. From O further up, you have to go 2 centimeters, and then 1 centimeter to get to the top cylinder, plus 3 centimeter, or the topmost point is at a distance of 3 centimeters plus 1 centimeter plus 2 centimeters, 6 centimeters from the base of the cylinder. The total distance of the topmost point on the base is 6 centimeters. A, B, C, D, E, F, G, H and J, K be 5 diameters of a circle with center at O. Wonderful. A, B, C, D, E, F, G, H and G, K. 5 diameters of a circle with center at O. In how many ways can 3 points be chosen out of A, B, C, D, E, F, G, H, J, K? 5, 6, 7, 8, 9, 10 and O, so as to form a triangle. And so any 3 points lying on a circle are non-collinear. So there are 11 points here. I'm going to break this down. We're basically saying from this 11, how can you select 3 points that are not collinear? I'm going to break this as some 10 of these. And so some 10 of these, out of these 10, you select any 3. They'll be non-collinear. Any 3 points on a circle are not collinear. Fine. Wonderful. Now let's think about O separately. And let's have O here at the center. Then out of the remaining 10, we can select some 2. That's the way to go about it. Take O and then select some 2 out of the remaining 10. That'll happen in 10C2 ways. However, if the 10 included A, B, C, D, E, F, G, H or J, K, then we're talking about collinear lines. This will not be a triangle. This will not be a triangle. This will not be a triangle. Those we'll have to subtract. Those we'll have to remove. So to 10C3, add 10C2. And then from this, subtract 5. The 5 selections of AB, CD, EF, GH and JK. AOB, COD, EFO, GOH, JOK will not be triangles. Pretty much anything else will be a triangle. So 10C3, 10 into 9 into 8 by 1 into 2 into 3. 10C2, 10 into 9 by 2 minus 5. So this is 3, 8 into 4, 8 by 2 is 4, 120 plus 45 minus 5, 120 plus 40, 160. You could imagine this as 11C3, 11 into 10 into 9 by 1 into 2 into 3. This is 3, this is 5, 15 into 11 is 165 minus 5. That's the other way of thinking about it. Effectively, out of the 11 points, select any 3. And then from that, subtract the selections of the 5 diameters. So 11C3 minus 5 or 10C3 plus 10C2 minus 5. Both ways we get to 160. The shortest distance of the point half comma 1 from the curve y equal to mod of x minus 1 plus mod of x plus 1 is, think about the point half comma 1, and from the point half comma 1 to this point, let's put half into this. If you put x equal to half, modulus of half minus 1 plus modulus of half plus 1. This is 1 by 2 plus 3 by 2. Y should be 2. Half comma 2 is a point on this line. It seems to be a very interesting curve. Y will be entirely positive. That much we know. I'm going to imagine and draw this curve, even if it takes a while. This is going to be, y is entirely positive. It's going to be a set of straight lines. I'm going to put a bunch of values. Let's say we put x equal to 0. Then y will be 2. 0, 2. When x equal to 1, when we put x equal to 1, we'll have 1 minus 1, 0, 1 plus 1, 2. 1, 2 is a point. X equal to minus 1, that will be a point here. And so x equal to 1 by 2, half minus 1 is modulus is 1 by 2, 3 by 2, y equal to 2, minus 1 by 2, that will also be a point. So think about this, a wonderful graph. And so I'm going to break this into 3 segments. And when x is greater than 1, this will be x minus 1 plus x plus 1. We're talking about 2x. When x is less than minus 1, this will be 1 minus x minus 1 minus x. It will be minus 2x. And so this will be a line like this here and a line like this here. Between minus 1 and 1, it will be 1 minus x plus x plus 1. It will be 2. So there's a point like this. It is 2 from minus 1 to 1, and then a curve with step 2x here and a slope of plus 2 here, slope of minus 2 here. Curves going up. You're looking at a point half comma 1. So half comma 1. The shortest distance will be this perpendicular distance, which will be 1 unit. Draw the graph. The key points here, if you're given just modulus, you're going to deal with straight lines. Keep that in mind. Best way to go about it, find points. Find the scenarios where put x equal to 0 and see if y can be 0. We can see where it meets the x-axis. Whenever you have modulus, break it along the modulus lines. What do I mean by that? X greater than 1, x less than minus 1, between minus 1 and 0. F of x equal to mod x. This means f of x equal to x when x is greater than 0, equal to minus x when x is less than 0, equal to 0 when x is equal to 0. You can put either of this as greater than or equal to or less than or equal to. Imagine that modulus equation like that, reconstruct that, and then you're through. Anytime you have only modulus come in, remember you're dealing with a set of straight lines. That is very crucial. That helps. Imagine the diagram. You put a bunch of points, you can connect them with straight lines, then we are good. A, B, C, D, F, E, F be a regular hexagon with each side of length 1 centimeter. So 1, 2, 3, 4, 5, 6. A, B, C, D, E, F. Now a regular hexagon is nothing but 6 equilateral triangles placed around a central point. Remember that. That's a very good way of thinking about a regular hexagon. Side 1 unit, 1, 1, 1, 1, 1, 1, 1, 1. All of these are 1. Right? Area of a square with side AC as one side. This AC. Think about this. If we call this as O, ABO is an equilateral triangle. ABCO is a rhombus. So this will be perpendicular and equal. So this will be root 3 by 2 times this. Altitude of equilateral triangle is root 3 by 2A. So we call this as P. So AP equals root 3 by 2 into 1, which is PC, or AC measures root 3 by 2 times 2, which is root 3 centimeters. Area of a square with AC as one side, if it's root 3 as one side, root 3 into root 3 is 3. This will be the area. The base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are of length 10 centimeters and 20 centimeters. So 10 and 20. Fine. So this is 10, this is 20. While the other two sides are of equal length. So let's say X and X. The perpendicular distance between the parallel sides is 12. So this is 12. This is 12. These two are equal, so it's an isosceles trapezium. So this should be an equal sides. So these two should be equal. This is 12. This should be 5. This should be 5. So X is 13. This is the base we are talking about. Height of the pillar is 20 centimeters. Then the total area in square centimeters of all 6 surfaces of the pillar. Remember that the pillar erected on top of this. And so that particular pillar will have as its sides 4 rectangles plus 2 trapeziums, one on the top, one on the bottom. For the 4 rectangles, one side will be the height. The other side will be 10, 20, 13 and 13. So we'll have 4 rectangles, one measuring 10 by 20, one measuring 20 by 20 and 2 measuring 13 by 20. So 10 by 20 area is 200, 20 by 20 area is 400, 13 by 20 is 260 into 2, 520. So we're looking at 520 plus 200 plus 400. So 1020. Sorry, it is 6 plus 5 is 11, 1120. This is the sum of the 4 rectangles. So far we have not accounted for this trapezium. This trapezium into 2 is what we need to account for. And area of this trapezium is half into 12 into 10 plus 20, sum of the 2 sides. Right? So 10 plus 20 is 30, 6 into 30, 180. 180 into 2, so 360. The 2 trapeziums, area would be 2 into 180, which is 360. So if we're looking to add 1120 with 360, we'll get 1480. So wonderful question. Key thing is to reimagine this diagram as a trapezium and another trapezium right on top with 4 rectangles sitting in between them. So we're looking at 4 rectangles, one with sides 10 and 20, one with 20 and 20, 2 with sides 13 and 20. On top of that, we are calculating area of this trapezium, multiplying it by 2. The points 2, 5 and 6, 3 are 2 end points of the diagonal of a rectangle. So 2, 6, 6, 3. if the other diagonal has the equation y equals 3x plus c, so some equation like this, this is the other diagonal, then what is the value of c? It's a wonderful question. The key to this is to know that this is a rectangle. In a rectangle, the diagonals bisect each other. So what does that tell us? That tells us that this diagonal should pass through the midpoint of this. So the diagram looks weird. This doesn't look like it's a midpoint. So chances are the other diagonal is like this. Right? So the midpoint of this is 2 plus 6 by 2, comma 6 plus 3 by 2. 2 plus 6 by 2, comma 2, comma 5, sorry, comma 5 plus 3 by 2. 2 plus 6 by 2 is 8 by 2, which is 4. 5 plus 3 by 2, 8 by 2, 4. So this equation, y equals 3x plus 2, passes through the wonderful point 4, comma 4, which is the midpoint of the other diagonal. Or you substitute x equal to 4, y equal to 4, this should be satisfied. 4 equals 3 into 4 plus c, so c not 2, or 4 equals 12 plus c, c should be minus 8, or we are looking at the equation y equals 3x minus 8. And wonderful question. So we are effectively using the idea that the diagonals of a rectangle bisect each other. That's all we need to do. That means this diagonal y equals 3x plus c passes through the midpoint of the diagonal 2, 5, 6, 3. Once you know that, you're through. ABCD is a quadrilateral inscribed in a circle with center O. And so ABCD is a quadrilateral. Angle COD is 120 degrees. So let's draw the COD first. It's 120 degrees. BAC is 30 degrees. So let's draw this. BAC. BAC is 30 degrees. This is the center O. Then the value of angle BCD. Fine. So this is 120. Right. Now this diagram looks a little weird, but it's a wonderful diagram. Angle B, wonderful question. Angle BAC is 30. There's angle on the segment. So angle BOC should be twice that, which is 60. You're going to have a tough time reorienting this diagram, but think about angle BOD. Angle BOD is 60 plus 120, which is 180 degrees, or BOD is a straight line. The diagram simply does not reflect that. Such is life. We could not have known that it will end up as a straight line. BOD is a straight line, or BD is a diameter of the circle. Angle BCD is angle in a semicircle, 90 degrees. Done. If three sides of a rectangular park have a total length of 400 feet, then the area of the park is maximum when the length of its longer side is. And so wonderful. Three sides are given. Let's say x, this will be x, this is y. 2x plus y is 400. The third side should also be y. X into y should be maximum. Right, so x or y is 400 minus 2x. X into 400 minus 2x should be maximum, or x into 200 minus x should be maximum. When is that maximum? Think about it. X into 200 minus x should be maximum. X into 200 minus x, that should be maximum. When x is 1, this will be 1 into 199. And x is 2, 2 into 198, 3 into 197. All the way 100 into 100. Go further, it will become 150 into 50. Further, we go all the way to 199 into 1. Think about this. 150 into 50 is 75, 0, 7,500. This is 10,000. The numbers keep on increasing till they become equal and then keep fall or their maximum when x is 100. This is 100, this is 100, this is 200, this is 200. Area of the park is maximum when x is 100 and y is 200. The length of the longest side, such as y, should be 200 feet. If three sides add up to 400, then 2x plus y equals 400. We can maximize x plus y. Sorry, we can maximize x into y when x is equal to 100, y equal to 200. Let P be an interior point of a right isosceles triangles ABC with hypotenuse AB. And the hypotenuse is AB. This is A, B, C. These two are equal. This is 45. This is 45. The perpendicular distance of P from each of AB, BC and CA. So from here, the perpendicular distance is equal, and each time it is 4 into root 2 minus 1. That means P is the in-center. When the sides are in the ratio 1 is to 1 is to root 2, I'm going to call it A root 2. And this distance, since all three are equal, we're effectively talking about P being the in-center. Or we have a right isosceles triangle whose in radius is 4 times root 2 minus 1. Or in any right triangle which sides A, B and H, in radius is A plus B minus H by 2. You should know this. When chosen a right isosceles triangle with A root 2, A plus minus root 2A by 2, A plus B minus H by 2 is 4 times root 2 minus 1. Or 2A minus root 2A by 2 is 4 times root 2 minus 1. I want to contrive a root 2 minus 1 here. So I'm going to write this as root 2A times root 2 minus 1 by 2 equals 4 times root 2 minus 1. Or A by root 2 equals 4. A is 4 root 2. So this side is 4 root 2. This side is 4 root 2. Area in square centimeters of the triangle ABC is half into 4 root 2 into 4 root 2. Root 2 into root 2 is 2. That disappears. We're talking about 16 square centimeters. From a triangle ABC with sides of lengths 40, 25 and 35, a triangle portion GBC is cut off where G is the centroid of ABC. Fine. So ABC G is the centroid. And so 40, 25 and 35. 40, 25, 35. Fine. So 5 is common. I'm going to think of this as, take out that 5. The ratio is 8, 5, 7. So whatever I find, I'll find for 8, 5, 7 and then incorporate this 5 later on. So 8 into 5, 7, 5 into 5, 7 into 5. And I'm going to think of this as an 8, 5, 7 triangle. And then BGC, G is the centroid of ABC. Area in square feet of the remaining portion of the triangle ABC. The remaining we need to find. To start with, one very interesting nugget that we should probably know is the centroid carves a triangle into 3 parts of equal area. BGC, ABG, AGC. They're all equal in area. So this area will be 1/3 area of the triangle. Remaining will be 2/3 of area of triangle ABC. 1/3, 1/3, 1/3. BGC will be 1/3 of area of triangle ABC. So remaining, what we need to find is the area of the remaining portion of the triangle. And this very crucial point, this remaining portion. I did this question completely once when I had the video up, where I had found the area of BGC and not the remaining. And so how do we go about solving this? We'll try to find area of triangle ABC and then take this number, multiply that by 2/3 and then we are through. BGC is 1/3, that is cut off. And so area of triangle ABG, how will we do that? We'll find the perimeter. I'm going to think about this as 857. Include this right at the end. Perimeter is 8 plus 5, 13, 13 plus 7, 20, or semi-perimeter is 10. S minus A, this minus the first number is 2, 10 minus 5 is 5, 10 minus 7 is 3. S minus A, S minus B, S minus C in some order. And so, our area of triangle ABC. And so, triangle ABC area is some multiplying factor because it's 5 times. The multiplying factor is 5 square, 25, into area of triangle of sides 875. Each side is 5x this. So every number will be 5 times that. Think of area as half into base into height, so that the factor gets involved twice over. The answer should be 25 into that. Now I'm going to do the computation. I know semi-perimeter is 10. S minus A, S minus B, S minus C are 2, 5, 3. So area is square root of 10 into 2 into 5 into 3. This is area of triangle of sides 8, 7 and 5. This into 25, because now I'm not thinking about 8, 7, 5. I'm thinking about 40, 35, 25. This into 2 by 3, because here we are thinking about remaining portion, not BGC, but the remaining portion. Fine. Wonderful. 10 into 2 into 5 into 3. Fine. So 10 into 2, 20, 20 into 5 is 100, or this is 10, 10 into 10, then the root 3 remaining. So 2 by 3 into 25 into 10 root 3. There's a 2 tens here. You take it out of the square root, it becomes a 10. So this is 250 into 2, 500 by 3 times root 3, which is nothing but 500 by root 3, choice B. Just a recap, the idea involved here, a centroid divides it into 3 equal parts. We want to find the remaining, that is 2/3 of the large triangle. Triangle has 40, 25, 35. Our ratio is 8, 5, 7. Find this and then multiply by 25. Because you've carved out, you've divided each side by 5. So there's a double impact, base into height, a square impact, an area impact. So 8, 5, 7, plug in our S into S minus A into S minus B into S minus C square root formula. Find the area and find the value.